Now, let's see if it matters. Now, if this breaks down to this, do you understand where this comes from?
Yeah.
This comes from that, okay. So this is going to be, if it dissociates this amount, right? Okay. Actually, this is not quadratic, but it could be. My apologies, this is not quadratic. What was I thinking? Okay, because if this were an x, then it would be quadratic. Okay, so what is 0.5 minus 0.0148?
0.4852.
So what is it? Do it on your calculator.
0.4852.
0.4852?
Yeah.
Is that it?
Yeah.
Okay. And then you'd say 0.0148 squared equals what? The tension is mounting. I can feel it.
Uh, 4.5.
144.
Times 10 to the negative.
What is it?
4.514
times 10
to the negative
4. Without the difference from the.
That's it? 4.514 times 10 to the negative 4? Is that correct? Are you sure?
Yeah.
And what was it before?
4.38 times 10 to the negative 4.
Excellent.
Not much of a difference. Why is this important? Why am I doing this? Yes, subtract it. Yes, not subtract it. Okay. Let's do this. Let's do this. What is? Let's make up. I want to make up a problem. All right. Let's do this. All right. All right. Let's do this. Why does it matter and why doesn't it matter? And this will bring us to the end of class, okay? Let's say I have this. That is acetic acid. That's acetic acid.
Wrong?
It's vinegar.
Oh, vinegar. I don't like vinegar.
Acetic acid. Vinegar. It's not vinegar, it's the pure acetic acid called glacial acetic acid. Vinegar is a dilute solution with some other things, like if it's malt vinegar or it's apple cider vinegar. It's just, or red wine vinegar. It's just a dilute solution of acetic acid, water, and a few other things thrown in. But the active ingredient is acetic acid. Well, this is the way we write. This is a short form way when we do chemistry. Let me hook that up to a power supply. Is it going off?
No.
There's like
It's low battery right now.
So let me quickly hook it up to a cable here. All right, there we go. We're back. We're rocking and rolling again. Okay. And this will take us to the end. Okay? This will take us to the end. Now, it says a short form way of writing this would be this. HAC. Just a short form way of writing acetic acid instead of writing all those H's and everything else. Because sometimes some students get a little upset by those H's there and stuff. Those H's don't enter into the acidic thing, okay? All right. It's a weak acid. The Ka for HAC equals 1.8 times 10 to the negative 5. Okay, that's the Ka, correct?
Yeah.
And it's going to look like this. HAC yields H plus AC. Okay? Yes or no? Yes or no?
Yeah.
This is probably one of the most important videos of the middle part of acid-base chemistry. Very, very, this is big, okay? All right, now, I have a 0.1 molar solution of acetic acid, okay? I want to know, what's the pH of that solution? Well, this tells me how much this solution is going to dissociate, doesn't it? This is called the Ka, which is the dissociation constant. It tells me how much is going to dissociate, correct? Yes or no?
Yeah.
So, if I start off with 0.1, I'm going to get X and X, correct? I'm going to get some sort of dissociation, would you say? And would you say that the amount of H plus is going to be the same as the AC,
Yeah.
right? And that's true, correct? Yes or no?
Yeah.
Okay, so the equation is this. The equation is Ka equals H plus AC over HAC, correct?
Doesn't it give you either H or H?
Well, aren't these going to be equal?
Yeah.
Okay, good. So I can say that the Ka is going to be x squared over HAC,
HAC is 0.1.
right? Can I?
Yeah.
And I can also say that this is going to be 1.8 times 10 to the negative 5 equals x squared over 0.1, correct?
Yeah.
Right? Isn't that correct? Now, find x. Find x. What's x? Put in your calculators. 1.8 times 10 to the negative 5th times 0.1. Take the square root. So let's do it together. Okay, 1.8. Do you see the shortcut you can take? Negative 5 times 0.1 is going to be what? You can just put in 1.8 times 10 to the negative 6th, right?
Yeah.
And then go square root. Where's square root? There's square roots. And then hit second again, answer, and equals what?
0, 0, 0.
What is the answer? If I take the square root of 1.8 times 10 to the negative 6th, what do I get? What do I get, guys? Come on. You have calculators.
1.3.
No, what is it?
1.34 times
No, 0.
0.00134.
So I get x equals, shall we keep it out of scientific notation?
Yeah.
Usually, you got to get used to writing scientific notation. It's very important, guys. Equals 0.000134. 3 centimeter figures.
Or 1.34 times 6.
Okay? Or 1.34 times 10 to the negative 3, right?
Yeah.
Okay? Is that okay? Can we write that? Can we write that?
Yeah.
Equals 1.34 times 10 to the negative 3.
Yeah.
And that's a concentration, right? Right? And what kind of concentration is that?
Oh,
Isn't that the H ion concentration? Isn't it?
yeah.
Right? Yes or no? Is that the H ion concentration?
Yeah. Yeah.
All right, now, take the negative log of that. Isn't the negative log of that equal to the pH? So pH would be equal to the negative log of the H ion concentration. 1.34 times 10 to the negative 3.
Equal 2.87.
So take negative log of that value. So log of the answer equals 2.87, correct?
Yeah.
So the pH equals 2.87. Okay, doable? You doable or not?
Doable.
Okay, good. So there's the answers. Now, did you write the answers down? Right? Okay, now. Well, I'm going to get rid of some of this. Okay?
Is there another way?
Yeah. Now, isn't this in reality minus x?
Yeah.
Isn't it?
Yeah.
Right? Right? So isn't it really x squared over 0.1 minus x equals 1.8 times 10 to the negative fifth? Isn't that true?
Yeah.
Yes or no?
Yeah.
So it's this times this equals that, right? So, what you would say is, you would say right. You would say, can I put this board up? Can you see the bottom of the board there?
Yeah, yeah.
All right, good. So you would say, let's do this. You would say 0.1 minus x times 1.8 times 10 to the minus 5 equals x squared. Isn't that true? Yes or no?
Yeah.
Okay, good. Now,
Wait a minute.
distribute this into here. You all right with that? Can you do that? What's this times 0.1? 1.8 times 10 to the negative 6, right?
Yeah.
Right?
Yeah.
Yeah.
Minus 1.8 times 10 to the negative fifth x equals x squared.
I like the other way.
Yes or no?
Yes.
Yes or no? Okay, now,
I like the other way.
I'm going to bring this on the other side. So I have 0 equals x squared plus 1.8 times 10 to the negative fifth x minus 1.8 times 10 to the negative sixth. Are you okay with that or not?
Yeah.
Wait, isn't it opposite?
Yeah, it is opposite. You bring it over.
No, shouldn't it be minus?
No, because he switched it to the next.
This is 1.8 times 10 to the negative fifth
Yeah.
x. That's what this term is here. See, you see? This term here is here. You see that? Michael, I'm talking to you, right? I'm answering your concern. And this is this, right? You okay with that so far?
Yeah.
I like to work from left to right. So can I erase all this stuff and get it off the board? Okay? All right, I'm going to use the property of symmetry and just say x squared plus 1.8 times 10 to the negative fifth x minus 1.8 times 10 to the negative sixth, okay? Now, it's going to be negative b plus or minus 4ac,
No, B squared
sorry, b squared minus 4ac divided by 2a, right? Right? Yes or no?
Yes.
Okay. Now, is the whole thing divided by 2a or just this?
The whole thing.
The whole thing, right? Right?
I like the other way better than this.
Yeah, that's why I said, I know, do you have to subtract it? I know, it's deadly, right? I know. Because you have the scientific notation and the quadratic formula, okay? I want you to sit down, and I want to finish this, okay? So, negative b, right?
Yeah.
Plus or minus
Square root of 1.85
1.8
times
times 10 to the fifth, negative fifth,
squared
squared, minus, it's actually plus, right?
Yeah, because
It's going to be plus, because that's negative, right? Plus 4a is 1, c is 1.8 times 10 to the negative sixth, right?
over
Divided by 2. All right? You okay?
Yeah.
All right, good. Now, could you somebody shut the door, please? I'm getting change of class here. Okay, we're almost there. Okay. All right, now. So this is going to be plus this or minus this. Which one is it going to have to be?
Plus.
Because it can't be negative. It's going to be the plus one. So we get rid of that negative. All right, right now, do this. Say to yourself, go this. Go on. Say clear. Say second. X squared. That's the square root thing. You're going to say
We're going to have to put the minus 1.8 first.
minus 1, what?
Minus 1.8
negative
times
1.8.
Negative 1.8 times 10 to the 5th.
Yeah, I like to do this first. That's all. I just like to do that particular. I like to do that first. It's just habit.
Okay.
So it's going to be 1.8 times 10 to the negative 5th squared, right? And then plus quantity 4 times 1.8 negative 6 equals. What do you guys get for that? What'd you get? 0.00268?
Yeah.
Is that what you got? So that's going to be negative 1.8 times 10 to the negative 5. It's a negative 5 up there. All right. Plus 0.00268 divided by 2. Okay? So then say minus this 1.8 EE negative 5, right? Equals divided by 2. Okay, so to finish up, this value here, if I put in second radical, I'd say this squared plus this times 4 times 1 times 1.8 times 10 to the negative 6th square root. That's 0.00268. That's here. And then I take the additive one because the answer has to be positive, right? And divided by 2 equals 0.00133. Now, so that would give you a pH, correct? Because that's the hydrogen ion concentration. All right, now, the question is, is it important to subtract, to get that subtracted value? Remember what we did. We said, let me erase this stuff. Let me erase all of this. Can you get that? You have that all set? Easy? The answer is 0.00133 as opposed to 0.00134. Not very significant at all. And that's really a fairly high concentration of acetic acid. We're going to be using concentrations that are less than that. So that's a high concentration, 0.1. So let me erase this. And I said, remember what I said? I said HAC, H plus AC. Is it significant to say, if that's 0.1, and that's going to be X, and that's going to be X, it's important to know where those X's come from, right? It's going to dissociate. at a rate, a small rate of 1.8 times 10 to the negative 5, I know that this is going to dissociate. Is it important to do that? And the answer here is no. It's not important to do that. Okay? You don't have to really do that. You can say it's negligible. Yes, that gives you a real pH. Yes, minor changes in pH, especially for metabolic systems, can be significant. But based on the number of significant figures we're using, 3 significant figures, it's only going to be off by 100th place. That's way within the bounds of round-off error. Way within the bounds of round-off error. So your answer is off by, let's remember, it's 3 significant figures, but tenths, hundredths, thousandths, 10,000ths, 100,000ths, it's off by 100,000th, tenths, hundredths, thousandths, 10,000ths, 100,000ths. So let me get this straight. You think that I'm going to care about a difference of 100,000th? No, I'm not. It's not going to happen. So it's not important that you subtract. And most of the time, I will have problems where you don't have to subtract that amount off. Yeah, with nitrous acid, it's a little bit significant. But I will tell you, I will say to you, do this problem and subtract. Do the quadratic equation. Apply the quadratic equation to this system. Easy? We're off.